Meeting being recorded. Yes, no problem. Recorded. Good morning, Marlu.
Good morning, Sayed. How are you?
Oh, wonderful. Good sunshine today.
Oh, it's gonna rain
Good
at
morning,
10 o'clock.
everyone.
It's gonna
Oh,
rain.
good
Morning.
morning.
Good
Rain
morning.
tonight? Rain?
Rain this
Rain
morning.
at 10 a.m. this morning.
That's what the weather said. 9 o'clock. Oh my gosh.
We need
Yeah, what is
water.
it? 80, 85, 90% chance of rain at 10 this morning, I think.
Correct.
Yes,
Yeah.
90%. Yes.
So just in time to drive to San Diego.
We need the rain. My plants.
We do need the rain. I had to water.
We need more water than they are forecasting.
Yes.
How are you?
Okay. Miss कर रही थी.
Good morning.
Good morning, Marcia. I see you're joining us today.
Wow.
And
Good morning. How is everyone?
Yeah.
Good
Fine.
morning, Marcia.
And Marcia wants to talk about the grant funding that I posted in the announcement last week.
Yes.
Yes. So I saw that Brian had posted that. So I'm really just here to remind you and encourage you to do it. I want to walk through the application really quickly. It is the shortest application I have ever seen for a grant. This one is worth $400 and it's due next Friday, which is the 12th. Okay. So let's, I'm going to share screen, Brian.
Okay.
Thought I was.
And even if you've gotten this funding before, you can apply for it again. I've had students that have gotten it because this is a different round, so it's a different process. So I have had students that have gotten more than one $400 check. I just wish I could apply for it, but it's for you guys, so you guys can do that. It's a very straightforward application.
Yes, it is. I mean, so the idea behind this funding is that it's for students who have been in some way negatively impacted by COVID, right? And we're going to walk through this really quickly. Some of you have done these applications before, but you'll see this one's even shorter. And, you know, there's going to be some questions on here about how you were impacted, but I believe I'm screen sharing right now.
Yes, you are.
Yes. Okay. So we're just going to go right underneath here where it says email confirmation to. So we always want to look out for the red dots, which is at the end of the sentence here, email confirmation to, which means that it's mandatory. And it's very important that you have or insert a correct email. That's how you're going to be notified, okay?
Yes.
Student ID, very important. First name, last name. Student type. So you all are going to put continuing education.
Yeah.
All right. Now it says, please select all that apply. So you can check more than one box. Okay. So it says, I have experienced employment hardship due to COVID. We could check that. I have experienced economic hardship due to extenuating circumstances such as COVID-19. Some examples would be rent, housing issues, or housing changes, utilities, groceries. I know my grocery bill has definitely.
I said, all you got to do is look at the price of baby back ribs and they've doubled. So everyone is impacted by that. So you should be able to check that because groceries, toilet paper, everything has gone up. So I know everyone can check that box.
Yes.
I've been waiting for baby back ribs to come back down. I used to be able to get them for $1.99 or $2.99 a pound. They've been up about $4.99 a pound. I mean, that's, you know.
Yeah, it's crazy
I'm
out
missing
there.
my ribs, let me tell you.
Well, you know what? You're gonna have to find a sale, and then you're gonna have to become a rib hoarder. You're
Yeah.
gonna have to buy all the ones at the market that day. We don't want you going without.
Yeah, I like stale meat, so I did a roast last week because they had nice roast. Nice
Oh,
cross rib roast with some potatoes.
Oh, did you cook it? Is
I
that
do
what
all
you're
the
saying?
cooking. I do all the cooking.
Really?
Yeah.
Oh,
Yeah, put it in one of my little croquet, actually for straw, cast iron enameled pot, put it in the oven. Good stuff.
oh, sounds delicious. Sounds so delicious. I'm teaching myself how to smoke. I'm trying to be a barbecuer or a smoker. It's
Yeah.
going slow. But anyway, I hear, you know what, there's someone that needs to put themselves on mute.
Yeah, let me see who that is. I think I got it.
Oh, okay. And then the other ones, you know, this one, okay, so, and then it says I've experienced an increased cost in course materials. You could select that too. And I'm just selecting these to let you know, so you can see that you can choose more than one. All right, and I'll let you read through these. And then now it just says, I certify or understand the following. I am currently enrolled in the current semester. That is yes for all of you, for sure. The information provided on this application is complete and accurate. Check that. My financial, personal, academic information may be reviewed to determine my eligibility for these funds. And it just says may be, it doesn't say that it will be. Additional information may be requested at any time. Requested in any information I provide may be verified. I think the longer I stay on Zoom, the worse my eyesight gets. I swear, this print looks like it's like, I don't know, like font 4. Okay.
Well, that's why I have big screens, Marcia.
You know what? I do have a big screen in front of me. It says, I understand that funding is limited and that an application submission does not guarantee an award, right? So this is a competitive process as well. They only have but so much money, and they have, you know, many, many students. So I want to urge you all to complete this as soon as possible. The last thing you're going to do is you're going to put in your signature by typing and hit send. All right, this is the easiest application I have seen yet, worth $400. You all have got to do this.
And the thing is most students don't. So even though there's only 1,100 things for CE, there'll probably still be some that are unclaimed, because there always is, because usually there's fewer people that apply than there is awards.
Yes, and you know what? I don't see it getting any easier. Take advantage of this opportunity, okay? You all, and like, you know, Brian said, there's gonna be folks out there that kind of miss the boat on this, and they might think that it's really a lot of work. I mean, I could see you all just getting that in if you have some time. Get it in this evening, because
I'll be doing it while I'm talking. I know them.
I mean, I don't know how long it might take you. Let's say maximum 15 minutes or 10 minutes. I mean, making $400 over the course of 10 minutes. I mean, I don't know. That's some real money right there. So that's all I really.
5 minutes.
Huh?
5 minutes?
Oh, 5 minutes.
Yeah.
You know what? That makes you probably in the upper echelon of American society if you make $400 in 5 minutes.
Yeah.
Pretty good.
Yeah. So remember, it's due by Friday.
Yeah. So just
But
get
see,
that knocked out, get it in. And like I said, I had students in my last class. I had some students that got 2 of them because they did 2 rounds last class. I had students that had gotten, several students that had gotten 2 $400 checks because they applied every time. What do I always tell you? If you don't ask, you don't get.
Right. Yes.
Marcia,
Yes.
this is the same email I received last week.
Yes. Same thing
Okay,
I
thank
sent
you.
you last week.
Yes, sir. I applied already. Thank you.
Ooh,
Good.
all right.
Yeah, I send that stuff out as soon as I get it, because sometimes it's first come, first serve. So as soon as I see stuff like this in my email, that's why you get an announcement. Because some days I get 20 things they want me to share with students. And a lot of it is either it already started by the time they send me the email, or it's stuff that just doesn't pertain to us. And so I really try to limit the ones I send out to things that I really think not only will benefit you, but you have a good chance of receiving that opportunity. So
Yeah,
Yes,
by the
Mr.
time I
O'Brien, you
send it out to you,
always follow
I've screened
the
them.
students. Thank you.
sir. First come, first serve.
So,
Excuse me? Well, I just want to give a shout out to those of you who've already done it. I trust the rest of you. If it applies to you, you're going to do it. And,
No, I said disturb her.
you know, like I say, treat yourself. $400, I could use it. I don't
me
know if there's
too.
any.
I wish I could apply.
Yeah, I know, huh? There's one day they gotta do one for, you know, for faculty and staff, at least one, you know,
Yeah.
throw us a bone. And so that's really it for today. I just, it's very rewarding for me when I find out that someone did get their grant. So that's what, you know, brings me here this morning. It's really kind of selfish. Once you get your money and you let me know, I get to celebrate with you.
Thank you much.
Thank you, Marcia.
You're welcome. You're
See ya.
welcome. Have a great morning or the remainder of the week. Yeah. Brian, I believe I'll be sending out, well, my goal is to send out like a video on graduation. There's a lot going on with that, but
Okay.
there's a lot of details that I need to sort through.
Perfect. And I will
Yeah.
be ignoring all of them, but I will pass them on to the students.
Okay, great. Oh yeah, and the ASEF scholarship is due on the 31st, you all. So I know that somewhere posted is probably an email that I sent out a few weeks ago. When you open the email, it looks really overwhelming, but just start clicking. It's 2 videos and an attachment. That's all it is. And it will walk you through completing that application. That application is more work than this little application that we're going to do that I showed you today. It's a lot more work. It's more thought needs to go into it, but it's also potentially more money. It's between 500 and 1,000. So you cannot wait to the last minute, because you're going to need to get an instructor or someone to fill out a referral, you know, regarding your character and all of that. So you can't wait on this one, because it's not just you. And
Did you ever get guidance on that for instructors?
You know, it went all the way up to STAR in terms of what, you know, the idea of,
And
you know,
we've
by
never
the, you know,
got anything back that allows us to go around FERPA on that. So I'm still waiting for direction.
oh, so what I did was I just took the initiative, because you know how you were saying they're admiring the problem or whatever,
Right.
however you put that. I just took the initiative to put a release down at the bottom of the actual form.
Perfect.
I did it myself. I
Oh,
just was
awesome.
like, you know, and so the student will sign saying, I acknowledge that, you know, my information is going to be reviewed. And I looked at a
Perfect.
couple
No, 'cause
examples.
We're here to help the students, but it's down to where I can't even tell a third party if someone's in my class. I mean, it's just
Yes.
regulated that far. If someone comes on campus, I can't tell them that this person is in my class and they're standing over there. That's a violation of the FERPA. So I mean, it's
Right.
really locked down what I'm allowed to do. So, and it gets in the way of us actually helping people. So I'm glad you did that. Thank you.
Yeah, it was, you know, like no results. And I said, you know what? Whatever that thing you said, they're admiring the problem or
Yep.
whatever. I was like, you know, I just got to handle this. So I think it'll be fine. And, you know, it's attached in that giant email I sent
Perfect.
you.
No, that should work.
Yeah. So you all, I really want to encourage you to do that application too, but that's not the kind of application that you start the night before. There's a reason why.
What,
Huh?
Amanda?
Which application is this you're talking about?
It's, I call it ASEF. It's a scholarship.
Automotive
application.
aftermarket scholarship or automotive foundation scholarship, something like that.
Is that the one where you could potentially win a new car?
Oh, no, that's the one you posted, Brian. I
Yeah,
don't know anything about that one.
yeah, that's another one. So I get stuff as I see it and I post. And if you want to send me that again, Marcia, I will post the link, or if you just want to send the link to the students, either one.
Yeah, that would be great because I'm not sure if I know which one you're talking about.
Perfect. Yeah. So if you can resend that, Marcia, and that way I send out with the videos and all the information in it.
Okay, I will totally resend that.
All right,
Thank
thank
you.
you.
Yeah, and I'm trying to figure out how I can win a car.
Yeah.
That one was fun.
Become an auto student. It's easy. Yeah, that was Ford. That was from Ford.
Mm-hmm, mm-hmm. Yeah. Okay, so I'll resend the link, and with that, have a great day, everyone.
Thank
You bet. Thank
You
you,
too, Marcia. Thank you.
You're
Thank you,
welcome.
Marcia.
Have a good day.
You too.
Well, it is going to be hard topping giving away money coming to talk about ignition. So talk about a letdown, but I'll try to see what I can do for you. So we're going to get into ignition systems. Ignition systems is a fairly large chapter. That being said, I have students that have already completed it and they survived. It has some extra credit in it also. But the ignition systems, when I go into ignition, we're going to start with true old school stuff we used prior to 1974. And we're going to look at how mechanical parts controlled the electricity. And then we're going to go through and see how it evolved to where we are today. And the reason why I do that is so that instead of just a magic box that does something, we can understand what each of the components in a modern automobile does, because we still have to do all the same things we did in 1955 to make the ignition system work. We just have other things doing the job. And so when I try to diagnose these systems, or when I see people diagnose them, they go, well, I read online it might be this, so I put one of these in it. Then I put one of these in it. Then I did this, where they're not thinking about what the job is of each of those components and what it does. So we're going to go through and build that foundation and then add in and work our way up to how we do a 2020 and understand the role of each of the components in it. So unless I'm running a diesel powered vehicle, we're using a spark in order to fire the air fuel mixture in the combustion chamber. So the purpose of the ignition system is to create a spark to ignite the air fuel mixture. The ignition system consists of a primary low voltage circuit and a secondary high voltage circuit. So we have a low voltage circuit that's a 12 volt circuit that might occasionally have 60 to 100 volts in it. And we have a high voltage circuit that's going to operate anywhere from 12,000 to 100,000 volts. So that's a fair amount of voltage. And that's what I was getting shocked by, for those of you that saw the power balance video, was the secondary ignition. So in order for the spark to work efficiently, I have to put the spark into the combustion chamber at exactly the correct time. So we're not going to look at how we make spark, but also how spark is timed into the 4-cycle event so that the spark's going to happen very close to top dead center of my compression stroke. And so we're going to talk about that a little bit. Let's see, can I get a little better? I guess that's better. So the key in the start position, the electrical connection is made between the vehicle battery to the primary windings of the coil. As the engine is cranked, a switch in circuit turns the primary coil on and off. In other words, we're going to flow current through the coil, stop flowing through the coil, flow through the coil, stop flowing through the coil. Every time we stop flowing through the coil because of electromagnetism, we get an inductive kick or a spike. And that spike is what generates the actual spark. So then high voltage is delivered from each ignition coil. If there's more than one of them on an older system, we only had one coil. As the high voltage pushes current across the spark plug, the air fuel mixture is ignited, causing the power stroke. So that is the process. So if I look at a basic ignition system, and this is what we have, it's called a breaker point system or a point style ignition system. So we use these on domestic vehicles until 1973, and we use them on some imports up until 1980. And so the original system, the contact breaker is open and closed as the engine's running. So we had these breakers in here, and we're going to get more into this, but we had these points, and there was a rubbing block here, in this case, 4 of them for a 4-cylinder. And then what it would do is each time it came on the edge here, it would open the points, stopping current flow. And when it went over, when it went over to the flat spot, it would close the points and allow current flow. So if I look at my circuit, I've got battery positive through the ignition switch, through the ignition coil, primary windings, through the points to ground. So this is my switch, the coil is my load. The reason why we see the ballast resistor here is that was used in the run position, where this would be used in the start position, so that I would have all the voltage available when I'm cranking the car over. But if I had all the voltage available while it's running, the points would burn up prematurely. So we would use our resistor, so less voltage would be used in the coil. And then as we advance, and I'm going to take apart each of these systems, so I don't want anyone getting lost, but I want to show you the different kind of, the book goes through and kind of evolves it a little bit here. So electronic ignition system, distributor type, in the US market, we saw it in 1974. There were some Europeans that had done it slightly earlier. First advance would involve replacement of the mechanical switch into now we have a pickup in here. And if I'm using a pickup, I need to use a module. So these work in conjunction with each other. Just as on the previous slide, I had the rubbing block on the distributor cam was my switch, opening was my trigger, excuse me. And then the points themselves, the contact points were the switch. Now, this is my trigger, the sensor, and the switch is inside the module. So, you know, the module, it's just a switch. So instead of, yeah, it's electronic. Yeah, it's a little computer. Yeah, it's filled with smoke. And when the smoke comes out, it doesn't work. But in reality, it's a switch. It's what's going to control the current flow through the ignition coil. The trigger tells it when, and then it controls the current flow, just like our old point system did. Then we moved into getting into where we would use a pickup. In this case, it could be in a cam sensor normally. And so now I'm using a pickup, a module, and I have 2 coils. So now we call this a waste spark system, which came out in the 1980s. And it's still used today. And this is where I fire 2 spark plugs with 1 coil. And what makes this system unique is I fire 2 spark plugs at the same time. So I'm firing at the top dead center of the compression stroke and top dead center of the exhaust stroke on this system. And the latest development we did is I now have a coil on top of each spark plug. So I have 4 coils, but I still have what? A trigger. I'm going to have some kind of signal down here. So either my switch is in the ECU or the module might be in the actual ignition coil, and we're just sending a signal here and it's controlling the switch. Somewhere I have to switch the primary current. So I have to have a module somewhere, whether it's in the ECU or whether it's in the ignition coil itself. I still have to have what? A trigger, a switch, a coil. I have to have these things. So as we go through these circuits, we're going to call out each of these and find where our trigger is, where our switch is, where our coil is, so we can see the commonality. Because if I know what it does, if I know what its job is, then I can figure out a way to test it. I'm no longer, oh, Google says this might be it. Let me order this part that might be expensive and hope for the best. I got a better idea. Why don't we test it? Why don't we understand what it has to do, and then we can test it. So primary and secondary current. So the induction coil converts relatively low voltage and high current flow into very high voltage with low current flow. And that's why I don't get killed when I get shocked with high voltage, because it's very low current flow. The high voltage side is the primary, the low voltage side is the primary circuit, and the high voltage side is the secondary circuit. A problem in the primary circuit will affect the output of the secondary circuit. So my primary circuit and secondary circuit mirror each other. They're going to look the same. The difference is the amount of voltage. And so I can see what's happening on the primary by looking at the secondary, and conversely, I can see what's happening on the secondary by looking at the primary. So all ignitions have these parts. We have a primary 12-volt system, which is going to be a trigger, some kind of switching device, and an ignition coil. My secondary ignition is going to have a coil, some kind of wire, and a spark plug. So you can see here the ignition coil is part of both systems. It's part of my primary system and part of my secondary system. I didn't list a distributor cap and rotor here, which we will look at. That's part of my secondary system because not all vehicles have it. Okay, so we may have other things. If you notice, I didn't list an engine computer here. I didn't list, there's things I didn't list because not all systems have them. But in order to operate, all systems are going to have these 5 components. So if I'm trying to look at my car and trying to understand where things are, I need to figure out what's the trigger, what's the switch, where's the coil? And we got the wire that goes from the coil to the spark plug and the spark plug. Is there something in the middle of the wires like cap and rotor? Maybe. Do I have a couple steps where I'm sending the signal from the trigger through a couple things like a computer before I get to my switch? Possibly. You know, we can make it more complicated, but I have to have these things. If there's something in between, all it's doing is moving the information between these things. This is still the order where everything is going to back to 1955 or to 2021. It hasn't changed.
The trigger, the relay.
No, a relay is a switch.
Difference between the trigger and the switch.
A trigger is synchronized to the engine revolutions, so it tells the switch to switch at the correct time. So the trigger has to be tied into the rotation of the engine. So that's going to be a cam sensor, a crank sensor, a rubbing block on the points, a trigger inside a distributor, electronic trigger. That could be a Hall effect switch, could be a trigger. But it's going to be something that is synchronized to the rotation of the engine so it can tell the switch to switch at precisely the correct time.
And which one has a high voltage, sir?
The secondary ignition.
No, but how we get the in engine high voltage 12,000 volt?
Right, because we're going to get into that when we talk about the ignition coil. So the ignition coil creates the high voltage from the collapsing electromagnetic field in the low voltage circuit. Because I have all this electrical energy I've built up in this electromagnetic field, and then we've stopped current flow. So that collapses, and we force it to go through the secondary windings through the spark plug to get to ground, because that now becomes the least path resistance. And so it amplifies it and creates that high voltage.
Yeah, it's too early to ask you for the high voltage, but I'm sure next we have the next to learn the high voltage.
Yep, we'll be getting there.
Yeah.
So this is out of the book. This is primary and secondary circuits. And it talks about some of the main components in the contact breaker system, electronic ignition with the distributor, electronic ignition with the distributor system, called a waste spark, and then a direct ignition system. So here's a kind of a list of the components I would expect to see in each of these systems. And you can see we've dropped out. This is not an all-inclusive list. And just like the system does, it always starts with a battery, then goes through the ignition switch. And, you know, we know it starts at the battery. And actually with the engine running, it doesn't start at the battery. It starts at the alternator. We already proved that. But this is where the book starts everything. Interestingly enough, it doesn't start the points ignition at the battery, even though it still needs power and comes from the same place. So it's not consistent or inclusive, but it does show you where it dropped down. So you see where we see triggering device. Well, the ignition module, that's a switch. We have an ignition coil, we have spark plugs and some wires. So
Mr. Brian,
yes,
sorry. So am I echoing?
you're not anymore.
So every time you start the car, you go through the first primary and secondary circuits?
Every time a spark plug is discharged. So if I have a single coil, so I go to an older car, one coil, and like my 95 Jeep, okay, so I got that I was doing the testing on, I have one ignition coil. I'm running at 800 RPM. And so which means I have 400 cycles, and I'm firing the coil 3 times per cycle. So that would be 1,200 times per minute. We're flowing current through the primary windings, stopping current flow, firing the spark plug 1,200 times per minute on my Jeep at 800 RPM. If I'm doing 1,600 RPM, it doubles. 2,400 RPM going down the highway, it triples, and so on. So I could be doing this 3,600 times per minute.
Oh, wow. Okay. Thanks.
Mind-boggling. It's hard to believe these parts wear out, especially these older systems with the points. There's a reason why points only lasted 12,000 miles if you were lucky. Because think about it, they're opening and closing that 1,200 times a minute or more. If it's 8 cylinders, it'd be even more. So you can see where that really gets big. So the ignition coil is part of which ignition system?
Both.
Primary
Oh.
and secondary.
Absolutely, both primary and secondary. It is the one component that is part of both systems.
Mr. Brian, so the primary and secondary don't have contact, right? The secondary gets the electromagnetic induction, right? And it has like a bunch more coils, so it collapses and goes like that to the spark.
Yeah, and they are connected inside the ignition coil.
Okay.
And I'll show you that on a picture I got coming up. So what we do is when we collapse the circuit, the path of least resistance is through the secondary windings instead of going back through the primary windings. And that's what induces it and all that. But yeah, it's all induced inside the coil. It's like magic. I mean, it can be magic pixie dust if you want. Like I said, I do have some pictures of the coils. We'll get down into it. I'll talk about how we used to test coils that doesn't work, but you can still do it today, but why you might not get a good result and how we test coils today. So I'll go through all that also. So the old school way is better than nothing, but I think we're more effective doing it other ways. And so we'll talk about that when we get to it. So Faraday's law, most automotive ignition systems use ignition coils that operate on the principles of the induction coil that you just mentioned, Chris. Automotive induction coils step up nominal battery voltage of 12 volts up to as much as 100,000. Faraday's law states that the relative movement between a conductor and a magnetic field allows 4 ways by which voltage can be induced into a conductor: as an alternator, a generator, self-induction, or mutual induction. And I don't expect you to know Faraday's law. It's not like Ohm's law or Watt's law that we actually use. So the value of the voltage from the 4 ways voltage depends on the density or strength of the magnetic field, the number of turns or windings in the coil, and the speed at which the lines of force are cut. In other words, how quickly can I turn it off? That's why we get more voltage out of an electronic ignition than we did out of a breaker points ignition, where we're opening this up and closing it. That takes, in fractions of a second, longer than a transistor can turn it on and off. So when we went from the old ignition system to electronic ignition system in 1974 on domestic cars, The big advantage of that was that we had a lot more spark, a lot more voltage potential to our spark plugs, which would keep spark plugs from fouling so quickly. It would also allow us to do a more complete burn of the air fuel mixture, lowering emissions. And so this was all brought about because of emissions. They didn't come out with electronic ignition because they wanted your car to last longer. They came out with electronic ignition because the federal government said you need to make your cars run cleaner. So in the induction coil, the secondary winding has many thousands of turns of fine enameled copper wire. The primary winding has a few hundred turns of relatively heavy wire by comparison. The maximum value of the secondary voltage is partly determined by the ratio or number of turns in the secondary winding to the primary winding, and by the value of the self-induced voltage of the primary winding. So that is where sometimes you'll see someone sells a performance coil. Someone sells a coil that's going to make more voltage than the stock coil. Well, what they're doing is that aftermarket coil is wound differently internally in order to generate more voltage. So that's how they do that.
Mr. Bryan, this sounds like a step-up transformer.
Yeah.
That would only be necessary, like the high performance coils would only be necessary if you're changing your engine to get like more compression or something like that, right?
Yeah, I mean, yeah, if you were going to run real high compression, it takes more energy to push. The higher the compression, the more resistance there is in the gap of the spark plug that the spark has to jump. So therefore, I would want more spark available. Now, modern vehicles, coils on them are capable of putting out, close to 100,000 volts. So even on the factory side, we've kind of eclipsed that, where performance coils used to be very, very common, where you had a distributor and you had one coil for the entire engine. It was very popular to see people buy performance coils to get that additional voltage. Modern coil on plug, we really don't see that because the factory stuff can already put out so much. That being said, as we generate that higher voltage, we generate more heat, and that shortens the life of the coil. So high performance is not necessarily high longevity. So even though our coils can put out, 60 to 100,000 volts, they normally operate while my car is running 90% of the time between 12 and 20,000 volts. Much, much lower, because it's the neat thing about this is it only generates enough voltage to complete the circuit. So it's not going to generate 100,000 volts if I can get to ground using 12,000 volts. So as our components wear, as my spark plug wires go bad, or as my plugs wear, and it requires more voltage, my coil will work harder and get hotter, causing the coil to eventually fail. So a lot of cars where the coil fails on it is because someone did not do the correct maintenance and replace the spark plugs at the recommended interval. And spark plugs can be expensive, but they're still much cheaper than ignition coils are. So there's a direct correlation there, because the harder it works, the more voltage it has to generate, the hotter it gets, the sooner the coil actually fails.
Mr. Bryan, I have a question.
Yes.
If we have two cars like a Camry and the size engine is 2.4 for both, and they drive on 65 mpg on the freeway, one hybrid, one regular car, which one is save gas? The hybrid, still the hybrid save gas? Or
Hybrid
spend the
should
same
still
quantity?
save gas.
Pardon me?
Hybrid should still save gas.
Oh, okay. Thank you so much.
You bet. And the MPG rating shows that.
Yes.
Okay, so required voltage versus available voltage. So this goes right into what I was just talking about. Required voltage is the amount of voltage required to complete the circuit or initially get current to jump the spark plug gap. And they use the spark plug gap as an example because that should be the point of highest resistance in the circuit. We're jumping across an open. Available voltage is the maximum amount of voltage that the coil can put out. So the coil may be able to put out 80,000 volts, but it only needs 10,000 right now. So that's all it's going to make. Higher required voltage or lower available voltage will prevent the spark from occurring, causing a misfire. So if I require more voltage than my coil can make, it won't complete the circuit. And that'll cause a misfire. Or if my coil is weak and can't make enough voltage, it will not complete the circuit and cause a misfire. But keep in mind, we're using low voltage to make high voltage. So if I have a voltage supply issue to my coil, a bad alternator, or I'm trying to start the car with a weak battery, I am not going to be able to make a good spark. So when we're jump starting a car, it's not just about cranking the engine over. I have to crank it over at sufficient speed that the compression heats the air fuel mixture so it will burn. And then as I'm cranking it over, I have to have enough voltage for my ignition system to work. And that's where that 9.6 volts comes in. 9.6 volts going even in the Wayback Machine was always the minimum ignition threshold voltage for cranking. So even though some modern cars don't want to go below 11 volts like BMW, because the computers get unhappy, my ignition system, if I get below 9.6 volts, we're not making enough spark. So you can get a car to crank over slow, but it's not going to heat the air fuel mixture. So you're not atomizing the fuel. And then you don't have enough energy to ignite the air fuel mixture because you're not generating a good spark.
Sure.
So that's where that battery, when your car doesn't start,
Ignition.
really comes in to where there's a lot of pieces to. It's not just about does the engine turn over. Gee, it's turning over slow, but it doesn't want to start. Well, we got to slow down and start with getting it turning over at the right speed, making sure we have enough voltage to fire the ignition system after we are cranking the engine. And that's where that cranking voltage becomes an issue. We don't see it as much anymore because the starters don't use as much energy. The engines don't require as much energy to crank over, and batteries are better. But still, if you have a car that sits or something like that, and you're trying to jump start it or you're trying to run it, that's where you got to sometimes be patient, let that battery get charged up. Over time, required voltage will increase while available voltage decreases, where that makes sense. My coil gets older, so it's not going to make as much as it did new. And my spark plugs are also getting older, increasing the resistance of the gap and requiring more voltage. Reserve voltage is above the required voltage, is used to prevent a misfire. And so what I mean by that is if we have something happen, I need to have enough extra voltage available to overcome that problem on that cylinder. So if I'm using one coil with 4 cylinders, each cylinder will get a different amount of voltage. If it's one coil for 8 cylinders, each cylinder will get a different amount of voltage, even though I'm using the same coil. And obviously, if I'm using 8 different coils, they're all going to get different voltage. But even with the same coil, since each spark plug is its own series circuit that we're flowing power through, because we're only going to flow power through one spark plug at a time on a conventional system, it's looking at what's the resistance for that circuit, and we're going to make enough voltage to overcome that resistance. And that's going to change whether I'm on cylinder 1, 2, 3, or 4. Now, they should all be very close to the same. But what if I have a spark plug that's starting to foul and get oil on it? Well, I would need less voltage because carbon's a conductor. And so that becomes cascading. So since I've lowered the resistance, we're going to have less voltage across the gap. With less voltage across the gap, we're going to foul more because I'm not burning the carbon off, which lowers the resistance. So again, it just cycles. So once it starts to foul, it gets progressively worse very quickly. On the other hand, say it goes the other way and it requires more voltage. That could be from a lean condition, could be from excessive compression.
It was his phone and he was sleeping.
Can you mute everybody?
I just did again. I muted that person once already. They unmuted themselves so they could talk to someone else. So,
Mr. Brian,
yes.
I'm sorry to interrupting. Good morning, by the way. I was going to ask you regarding about the previous slide that you were mentioning. So I just got, thinking about like, let's talk about, I don't want to be specific on a car, but like you mentioned, in order for that spark to jump that little gap, it's usually like around, like you say, like 15,000 volts. And if you use a performance ignition coil, that is capable to go up to like 100,000 volts. You can modify that gap. I mean, if the coil is capable of doing it. And now my question.
Yeah, you could. And there are times when people do. I know I'm going in the Wayback Machine here, almost 40 years ago. I knew a guy who worked with a camshaft company, and they were able to adjust the horsepower of an engine by 14 horsepower just by playing with the spark plug gap on the dyno. So yeah, absolutely. Race guys do that. On, cars on the street, we don't. You want it to last a long time, keep it stock. Even if you go out and buy that high performance coil that's capable of more voltage, it's only going to make as much voltage as it needs to complete the circuit. So if you're running, like you said, stock spark plugs, stock engine, stock everything, you've spent a bunch of money and you really haven't gotten anything.
Yeah, because it seems to me that it seems that the compression engine, the fuel doesn't get burned 100%, because some of it goes to the cat, to get burned. Now, if you use a bigger gap, you have now a wider range of spark to ignite that mixture. So is it like more efficient, or am I missing something here?
No, you're not missing anything. And the engineers in the late 70s and 1980s did just that. So for years with point ignition, we ran around a 25 to 32 thousandths gap, depending on the manufacturer. When we came out with electronic ignition, we started seeing 40 thousandths, then 60 thousandths. And then even GM made some cars with an 80 thousandths gap. So 4 times the gap what we did with points, or almost 4 times the gap. And we saw that in the 80s. And the idea was to burn cleaner. By the 1990s, everyone pretty much came back to that 40 to 45 thousandths gap for electronic ignition. And that's where we're at today. So there must, because they follow that same thought process in the 80s. GM did this, other manufacturers did this, where they really opened up that gap, trying to get more burn and lower emissions. And the reality is that was really a result of poor combustion chamber design. And once they redesigned the combustion chamber to be more efficient and create better turbulence and control of the flame front, they didn't need to have that bigger gap that caused coils, distributor rotors used to burn through. We used to see all kinds of fun stuff from that. But now they're able to lower that so they get better longevity, and they're still getting even better emissions than they did when they had that gap up at 60 or 80 thousandths. So that's why we're where we are today, is because at first they did exactly what you said, Alberto. You're on the right track. You know what? We need to burn cleaner. Let's open this up. And it did. It burned cleaner. But again, keep in mind, they're still using a 1960s, early 70s engine design. As they redesigned engines and understood airflow and volumetric efficiency, and there's been books written on this, on what's called the flame kernel, which is that basic spark where that flame initially starts and how you control that flame kernel burn with the turbulence. There's been some really good books written on that. I mean, it's a whole separate thing. You need an engineering degree to understand half the stuff. But it does go in and really talk about that. And what they're doing now is they're really controlling airflow and turbulence through induction, the intake manifold, exhaust manifold, and combustion chamber design, including what the top of the piston looks like. So some of these now pull air in, they tumble it, they move it around to a smaller part of the piston where the spark plug hits, and the spark plug ignites it. We also have what's called indexing of spark plugs, which I'll get to when we get to spark plugs, that further optimizes that. So no, your thinking's not wrong. It's just 30 years, 35 years.
So there is there is a little room there. I mean, good thing now. I mean, yeah, the way how I see it, the the spark is not being controlled. I mean, let me back up because I don't want to say it wrong. The voltage that it needs for the spark to jump the gap is pretty much controlled by the gap itself. It's not controlled by the computer yet.
Right. And that's why, like in this example here, what I'm looking at is an ignition pattern from a scope. In this case, it could be an ignition scope. If I'm looking at secondary, primary, it's going to look exactly the same. The difference is it won't have thousands of volts. It'll be actual volts, but the pattern will be the same. So if I look at the top here, the firing voltage is when we open the switch. We stop current flow through the coil, and I get my inductive kick, and this is where we fire. So this is how many volts. The next is my burn time. So right here, we've opened it up. The coil is fired. We've completed the gap. Now I'm going to burn across the gap for this long until I no longer have enough energy to maintain that circuit. Once that happens, the circuit collapses, and we get 3 to 5 what are called coil oscillations, which are these little waves. And what that is that's energy that's left over in the coil, but it's not enough energy to stay jumping across the gap. So that energy we kind of call like death throes. It just kind of does this. You have to have 3 to 5 of those. If I don't have those, that means my coil doesn't have any reserve capacity. So that's the first place I look for a reserve capacity on the coil. Now my circuit is off, and then we come back down and we turn we cycle current through the coil again. And so this is the started dwell, or points closed, as we used to call it. Right here, this is a modern car. It does what's called current limiting. So this little spike here is because, hey, we've saturated the coil. We want to limit how much current we go flow through the coil. So that's why you see that second bump here. That's not typical. I wish they hadn't used a current limiting example. It just makes it more complicated for your first one. And then primary current off, and it starts all over again with our inductive spike. So we have one of these. If I'm on the coil, I have one of these for each cylinder. And so we can see right here, it pulls out in the book what my available voltage is. So an open circuit misfire. So you see I have a lot higher voltage here. So if they're all normal and I have one high, that's typically a bad spark plug wire. Most common cause is a bad spark plug wire, where the spark is jumping across outside to metal from a spark plug wire. So that's normally a bad spark plug wire. It can also be a broken spark plug, unusual, but it does happen. But that's normally a bad spark plug wire. It could also be that I have a very, very super lean cylinder, but if that was the case, I still wouldn't have it that high. So that's like an open circuit. So if I unplug a spark plug wire, forget to plug something on, I would see something like that. Over here, I have a shorted misfire. So the richer the mixture, the more fuel in the combustion chamber, the less resistance. Less resistance means less voltage is required to jump the gap. So if I have a fouled spark plug from fuel or oil, whether that's from low compression or whatever the reason, but if I have a spark plug that's fouled, it'll show me low voltage, and that's a misfire. Here would be normal voltage. So what we would do is we would hook up, if I had a misfiring car, and I would look, this is a parade pattern. We got them all lined up in a row. And I would look to see, are they all the same? Well, I got 2 the same. I got 1 high, 1 low. Man, I'm amazed this car runs. So this is what we did prior to having a computer that would tell us what cylinder is misfiring.
Let's don't go that long. I want to know if blood sugars are okay. So let's make an appointment.
So that is what we're seeing. So we don't use secondary ignition hardly. We don't use this pattern really anymore, unless I'm working on something really old. What we will look at though is I'll look at this pattern right here on many vehicles on the primary side, because this is still something I can see with a lab scope on a lot of vehicles. So since I have a code for a cylinder that's misfiring, if I have a cylinder that is not producing spark, I can go take a look and see, is the coil being turned on? And so this allows me to figure out, is it a coil or is it something else? Now, many times I won't do this because what? If I have multiple coils, I can just move the coil from the cylinder that runs good to the cylinder that runs bad and swap them and see if the cylinder that runs bad moves, right? If I'm working on a 4-cylinder Honda, that's the easiest thing to do. Move a couple coils around, move from the cylinder that's working to the cylinder that's not working. And does the cylinder that's not working move? If it does, it has to be a coil. But there are cars that accessibility prevents us from doing that. For example, maybe I have a V6 and it would take a couple of hours of disassembly and reassembly to move a coil from one cylinder to the next. That is when I'd want to look at a scope pattern, because I can look at that. So even though we have the technology to do these things, we don't necessarily do it on every vehicle because it's not always the most efficient way to diagnose a problem.
So Brian, do modern cars still use a distributor, or is the ignition coil directly connected to the spark plug?
We no longer use a distributor on modern cars, so they are almost directly connected. They still have a short wire, oftentimes called a coil boot, that goes between the coil and the spark plug. We also have some that use short wires where the coil is mounted near the plug, and they use a 6 or 8 inch long spark plug wire to connect the coil to that. And we do both of those things today. Currently, no one is using a distributor. So the last common production car using a distributor would have been Nissan in 2003, 2004 on the 3.3 liter. 2003, 2004 they went to the 4 liter. So 2003 Nissan, like an Xterra or a pickup truck. And then the Chevy vans, the 3/4 ton vans that had a 4.3 liter V6 in them, ran a distributor, I think, up until 2010. I'm not quite sure on the end year of that.
Yeah, so just a follow up. So if I were to diagnose an ignition problem, I would look at the 3 major components: the battery, the ignition coil, and the plugs.
Well, the battery, we need to make sure I have a good battery, but don't forget about the trigger and the switch. So if the computer doesn't know the engine's going around, like a bad camshaft sensor, it's not going to fire the coil.
Okay.
Right? Because if it doesn't know the engine's going round and round, why would it fire the coil? Because it's supposed to fire the coil at a specific time. So I have to have a trigger. My switch has to work. So this is a way I have of seeing if my switch works, the scope. I can use a scope on a trigger. I can use a scope on a switch. I can see this. I can see if the coil should be working by this, and I can test the output of the coil with voltage that I'll also get to. So, so we really, so today we use quick testers and we use scopes primarily for doing this, but it's because it's really about what is the job of each component. So one ignition system Volkswagen uses what's called an ignition amplifier. So it goes from the computer to an ignition amplifier to the coil. Well, we had a Volkswagen that didn't run, and we had no documentation on what the ignition amplifier did. But I know a stereo amplifier makes things louder, doesn't it? It amplifies the signal. It makes it bigger. That's what an amplifier is. So what we did is we took a scope and we looked at the signal in and the signal out of the amplifier. And we saw it was the same. It wasn't being amplified. So even though I was getting a signal to the coil, it wasn't high enough to tell the coil to fire.
Yes.
It needed an amplifier, but it proved the computer was good. It had a signal in, signal out. It's an amplifier. It looks the same both sides have. It had to be an amplifier. And that was the first one we diagnosed. We saw a lot of them go bad after that. But of course, the first time diagnosing something with no real documentation, well, I know I got to have a signal that comes from a trigger to a switch to the coil, right? I have to do these things. So I can use a scope to look at that signal. I don't need to necessarily understand all of what it has to be, but I'm kind of looking, is there something moved? And then once there's a signal, now I need to go, what kind of signal is that, right? Is it a permanent magnet sensor or a Hall effect for my speed sensor signal? Is the computer sending out some kind of on-off signal? Because we know a flat line is never good, right? Flat line is something's dead. So, it's true with people, it's true with on cars. So so we can, again, it's about asking questions, because there's no book, there's no reference information that's going to give you everything you want. All we can do is ask questions, look at things, analyze. And
All
that's
the
how we
five,
learn.
all the five components have sensors?
What's that?
The 5 components have sensors?
Well, the trigger is going to be some kind of sensor.
Question, Mr. Brian.
Yes.
I like his question for the modern cars, but why we have to study the distributor, which is old fashioned?
Well, first of all, because they're still in the smog program. So anything 1976 and newer is still in the emission program. So I'm required to teach it. Aside from that, the reason why I go all the way back in my Wayback Machine to points is because if I can understand what I can see, then it doesn't take much to understand, oh, that thing that used to open and close, now that's in a computer and it's electric. Okay, that's easy because I have something I can visualize. And now I'm just telling you, yeah, we put that thing, you can't see it anymore, but it's in this little plastic box. Okay, I get that because I understand the function. So after teaching ignition for 11 years now, for the last 11 years to techs, because I taught it before that, I have found the best way to do it is to start with points and move up. When we've jumped right in electronic ignition or jumped right in at modern systems, there's a lot of confusion over what each of the components do, and they're not understanding the current flow from what it is, which is a simple series circuit, and we're flowing current through the coil. So how do we know when to flow current, right? That's a trigger, right? Who's controlling the flow? That's a switch. So we can really visualize that on a points ignition system. It's easy to take that one jump to an electronic distributor system before we jump into having to use cam and crank sensors.
Yes, thank you. It makes sense.
Yeah. That's what the whole idea is, to try to make sense out of something that can be very confusing. Because to be honest, the ignition coil is probably one of the most confusing things on the automobile. When I went to school, we have to learn, we spent a lot of time on them. At that time, we used an ohm meter to test them. And I'll go into why we really don't do that anymore, although you still can. And yet, even with all of that, it was still a mystery as to how does it get from the primary to the secondary? It's like magic, right? And so what I try to do, again, being a kind of dumb guy, well, I know what the secondary should do. It should put out a lot of spark. So if it's putting out a lot of spark, it's working. I don't need to test anything else. If it's not putting out a lot of spark, then I need to look at the primary to see, is it being told to put out a lot of spark? So why do I really need to test it? I can test the primary, right? Is it being told to put out spark? I can test the secondary. Does it put out spark? Right? So if it's not putting out spark, but it's being told to, it has to be bad. And the issue with using an ohm meter is you'll have coils that test bad with an ohm meter that work just fine. And you have coils that will test good with an ohm meter that don't work at all. And back in the 80s, that's how we tested things. And we made a lot of mistakes. We put a lot of coils on cars that didn't fix it. We also had cars that took us a couple of days to figure out. And it turned out to be a coil that tested good because we were testing it with an ohm meter, which is how we were taught. And so that's where you see this evolution in testing of, wait a minute, how the book says doesn't work, kind of like our thermostat example yesterday. Let's look at the two sides of the system. If I have an input but no output, the device has to be bad. If the device isn't giving me an output but it has no input, that's not the device's fault. And that's true for anything, whether we're talking computer components or anything else. So we can apply that to our coil. What's that?
Oh, the other thing I was just going to say, timing. Timing is important too, because I'm just going to say a little story that happened to me a while back. I was diagnosed in a van. It was a 2001 Chevy, the V8 motor, and I had spark. The rotor inside the distributor was rotating. I saw it physically rotating. I didn't have the scope, so I was just doing everything, like manual. And I had a signal from my crank sensor, cam sensor, and I had fuel. I had pulse on the injector. I had compression, and I was scratching my head. I'm like, what is going on? I mean, I have everything in order for this guy to run. So what is happening? And it just died. The guy was like driving up the hill, and it just like stalled out. And so I pretty much started, I kind of like, I back up. I say, you know what? I'm gonna start from scratch again because I'm pretty sure I'm missing something here. Sure enough, as soon as I removed the distributor, the shaft inside the distributor was broken. So that thing was turning, but it was in the wrong place.
Right, in the wrong place. And that's because it's a two-piece shaft on a lot of distributors, which allows for timing or advance, depending on the year of the distributor. But yeah, I have seen things break. But no, we're going to get into timing because our spark only does us good if it gets to the correct cylinder at precisely the correct time. And even being off by a couple of degrees causes a problem. So here it talks about components to all systems. Most ignition systems, they got the battery ignition switch and ignition coil, secondary wires or high tension leads or spark plug wires and spark plugs. It talks about the batteries are source of energy. The ignition switch connects that energy to the coil. And the ignition coil is needed to amplify the battery voltage to get to our high voltage. High tension leads transmit the high voltage from the coil to the spark plugs, and the spark plugs provide a spark to jump within the combustion chamber. So we have lock positions on an ignition switch, and we have on and run crank, and those can be different positions depending on the generation and the design of the ignition system. So a lot of ignition systems have a separate power feed from the ignition switch for the run position than the crank position. The accessory position does not provide any power to the ignition system.
आवाज सुनने के लिए हमें इतना नजदीक करना पड़ा वरना स्पीकर लगा.
And they do that to prevent the ignition coil from overheating. So if I was in an old car that had points, if I left the key on and those points were closed, we would be flowing current through the coil. And it would do two things. It could burn up the points. The other thing it would do is it would heat the coil so much that it would start leaking the oil out of the coil. And there's oil in the coil for cooling on traditional coils. And they actually have liquid oil inside on a regular round ignition coil like most of you have seen. Now, a lot of the new ones, they're using different technology on the coil on plugs to get rid of the heat and dissipate it. But a coil really hasn't changed that much in a long time. So if I look here, this right here is an ignition coil. And what's more, it is a Ford ignition coil. I don't think it'll work on your Ford. And yes, this is wood. And it has our stuff here for the coil. So this is an old school coil, about 100 years old. So it's amazing how many things really haven't changed that much. We're better at them, but the basic technology hasn't really moved. So that's why we have an accessory position, is so that we can go to accessory and not power up our ignition system. On newer vehicles, that's not such an issue. And we're actually seeing where some of these push button start vehicles are actually getting rid of the accessory position. Again, with electronics and with all that, and we now have a crank sensor, we know if the engine is turning, we can just power stuff down until we see the engine turn. Now we can activate it and do this. We have to worry about that stuff overheating anymore. Ignition switch contains two different parts, a mechanical part and an electric part. And then the key is the same way. Many keys today also contain two parts, the physical key and a chip or a transponder that lets the car you're working on know that that key is authorized to start the car. Many automatic transmission vehicles, the ignition switch is also a transmission shift interlock, or you can't shift out of gear unless what? Your key is in the ignition and turned. and you put your foot on the brake, and. So ignition switch is going to provide power to the different circuits, and Rob has a lot of experience with ignition switch lately.
How would you get a master key if you lost it for one of the newer cars?
Order the key from the dealer by the VIN.
All right. Yeah, it's good enough. I noticed some people lose his keys a lot.
Yeah, as long as you have a key, you can get one made. But if you lose the keys altogether for a car, you can order up a key by the VIN. You got to have the registration, prove you own it, all that stuff, but you can get it.
All right.
Mr. Brian?
Yeah.
In Alberto's example, would the shaft be the trigger and the rotor be the switching device?
No, the rotor is strictly a connector for the secondary ignition. So the distributor is the trigger, and that's going to go to an ignition control module. And the ignition control module is the switching device.
Okay, so it's not just the shaft that's the trigger, it's the entire assembly that's the trigger.
Well, it's really the pickup sensor, or in the case of points, the rubbing block that's touching the shaft. So it's that combination of that rotating device and the sensor. So a trigger on a modern vehicle might be a camshaft sensor or a crankshaft sensor, right? Because it's watching that shaft rotate. So it's something that's picking up that rotating shaft. So certainly in the case of a distributor, if it wasn't turning, we'd get no trigger because the device that's mounted to it wouldn't see any rotation.
But here's what's confusing me. I guess I'm used to going from a coil to the distributor to the plug.
Right. Which is your secondary ignition.
Right. So that's only 3 steps.
Right. Because you're only looking at the secondary side, which is your high voltage side. So you're going from the coil to the distributor, and from the distributor cap to the distributor rotor, back to the distributor cap, out another wire to a spark plug. And I got some pictures coming up that's going to illustrate this.
Okay.
For those of you that are kind of glazed over. And then my primary side is that whole different circuit. The primary side uses the trigger. And what's that?
No, I was going to add that the cam sensor actually is inside the distributor. That's why it was having the issue.
Right.
But yeah. So right inside.
Right, because I was thinking that it was the shaft, because as we turn the distributor, then that changes where we think top dead center is. So
right.
I was thinking that the shaft was the trigger, because that's what's really telling us when to fire.
Well, you're close. It's the sensor on the shaft that's the trigger. So the trigger is aligned, hopefully correctly, to the shaft, so we get the right information.
Shaft here is crankshaft or camshaft?
Well, he was talking about the distributor shaft.
That's the camshaft. The camshaft is inside it.
Yeah, but the distributor is normally driven by the camshaft, but the shaft that Rob was talking about was actually the distributor shaft.
Oh, you have to think of the Wayback Machine, Alberto.
Yeah, we're gonna get there. I got pictures, so give me patience. This is there's a lot of slides in this presentation, and we're only on 26. So I have a lot of pictures to try to break this stuff down as we get there. So, I'm kind of starting at the battery. I didn't go, which is what the CDX did. I left the ignition switch in. I took the battery stuff out because we've already learned about batteries. And now we're at the ignition coil. And the ignition coil is the only part that's in the middle, that's in both the primary and secondary system. So it allows us to look at both. But we're going to take a little look at the ignition coil. And it is a step-up transformer. Where did we hear that already this morning, Rob?
Hey, thank you. I should get a little salary here.
So, what did I say? Yep, basically. So electrical device that amplifies low voltage to very high voltage. 2 sets of windings in the ignition coil, the primary winding, the secondary winding. So if I look here, we can see I have a positive terminal, which is going to go to my power source, ignition switch, whatever. and a negative terminal that's going to go to my switch. So that switch can be my breaker points. If I go old school, it could be my ignition control module, whatever. It goes to my switch. So I have power going through the windings all the way over to my switch. And we're going to build up an electromagnetic field on this iron, around this iron core. Now we open the switch. The field collapsed and we get an inductive kick from that. Well, if you notice, my secondary winding is tied into this side, the negative side, before the windings. So that forces the power to come through here. It's going to go through those lots of fine wires out the high voltage tower to my spark plug. So we're flowing current through the blue here. As soon as we stop flowing current through the blue, the kick comes back here, goes to the brown wire, goes through the fine brown wires, up and out the high voltage. So that is what we see.
Mr. Brian?
Yes.
This is like, you know, it's hard to me to understand this part, because if you look at the picture here, so you have the positive terminal and the negative terminal. See, they're connected on the same blue wire. But so I'm assuming that that wire is made of some sort of is it copper? I mean, most of the time it's copper, am I right?
Copper wire.
How come it doesn't short out? That's because, I mean,
because it's laminated. It's just like your stator on an alternator, or the armature on a starter. Even though the wire is wrapped on top, the wire is what? Sealed from each other.
They're not physically connected now.
Yeah, exactly. Okay. So there's only one connection, which is between here. I got one path, even though I've gone around here 20,000 times. I'm a little tired. And then I finally get to go out the top.
Question, Mr. Brian.
Yes.
Like a step-up transformer, the primary coil and secondary coil, but there is an iron core.
Right.
There is an iron core in the transformer when you boost the high voltage from primary to secondary.
Right.
But here, I understand they have the HT tower primary winding 200 turn and secondary winding 20,000 turns. But where is the core, iron core to build
up? The iron core is right here. It's in the middle. I already pointed it out right here. Iron core. That's what all the windings are wrapped around.
Oh, that's iron core, laminated soft iron core. Okay, I got you.
So you're right. I have to have an iron core.
Thank you.
You bet. So we're never going to open these up. We're not going to take them apart. This is there to try to help some understanding. And this is also, if I'm using an ohm meter, they give a resistance specification for between the negative and positive terminal, and the negative terminal and the high tension terminal. And so those are the two resistance specs they give for the low side and high side resistance. But many times brand new coils are out of specification and they work just fine. So that's why we don't do the resistance test anymore, but you will still see it in the book. And obviously, if you don't have a scope, you don't have anything else, doing an ohm meter test is better than nothing. But we have some other ways we can go in and do it under the shade tree without an ohm meter that actually give us almost better information with less work. So the ignition system of late model vehicles requires a minimum of 30,000 volts when tested, even though it may only use 10 to 15,000 volts during normal operation. So we use a calibrated spark tester in order to verify that my ignition coil makes enough voltage. And so, you know, open circuit voltage potential can be 40 to 100,000. That's great. What I can tell you is if the coil doesn't make 30,000 volts, we have a problem. So we use a calibrated tester for that.
Mr. Brian?
Yes.
Is this what they're talking about required? So the 30,000 is required, and then the 10 to 15,000 is what's available?
10 to 15,000 is what's used during normal operation. So in other words, I might need 30,000 volts to start the car, but only 10,000 volts to run the car.
Okay, thanks.
So if I'm testing a car that doesn't run or testing a cylinder that's misfiring, what I do is I go in and I test for this 30,000 volts. I make sure that that's there. And that's a real quick, low tech test. And if I have 30,000 volts going to the spark plug, guess what? Either I've got a bad spark plug or something else is wrong with the cylinder. I mean, it's just a real quick, go, no go. Either it's good or it's bad. There's no ambiguity about it. There's no, gee, I wonder if.
How
And
do you test it?
well, let's see. I'm trying to think, did I put the picture in or not? I actually didn't. Okay, so we will do this. So how we test it, let me pull it up here. Okay, so let me do a different screen. So this is a 30,000 volt spark tester. So this is made by OTC, has the part number here, 6589. And what this is it looks like a spark plug, but there's no center electrode. So if you notice, there's just a hole here in the middle. So it's calibrated for the 30,000 volts. They make one with a spark plug that has a center electrode. That one's 12,000 volts, which is what I'd use on like a lawnmower or an old points ignition vehicle. But anything since 1974 with electronic ignition better kick a spark across this, and you'll hear it. You'll hear a snap, 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 snap. You'll not only see it, but you'll hear it. So can I use a screwdriver and put a screwdriver in and go, yeah, do I have a spark? Yes, that'll tell me if I have a spark. How good is it? Then you get into, well, is it yellow or blue? How far away am I? I've seen a lot of cars misdiagnosed doing this. I like this, and this is what I use. This is real simple. I plug it in, either it's good or bad. Either it makes the spark or it doesn't. The other advantage this is when I'm working by myself is I can clip this underneath the hood, go inside and crank the engine over, and I can hear this from inside the car. It's loud. So, of the tools that are just go-to good value tools, if you're going to do any kind of, diagnose on ignition, this is a great first step tool that tells you whether or not you're making spark. And it just, I have 2 of these in my box. I think I own 3 of them. I lost one once and I found it again. But this is a go-to use everyday tool in a shop if you're doing drivability work. So not all real cool tools are real expensive. So I do know I have some people in here that do have tools that are working on their own stuff that might find this of interest. And if you're not, at least you know a way of testing. So this is a lot cheaper.
Mr. Brian.
Yeah.
What's the thing that it's holding the spark?
What's that?
What's that thing that is holding the spark?
This clip right here?
Yeah, what's that?
Well, that's just where it clips to ground because I have to complete the circuit, right? Because I'm going to connect the spark plug wire at the end, or the coil, if it's coil on plug at the end. It's going to come down through the center, jump across here, and then the energy has to what? Get to ground. So I either need to clip this to ground, or I need to use a jumper wire to ground if there's nothing metal around it to clip on. A lot of times I can clip on a valve cover bolt or an intake manifold bolt or something like that. And you'll see me do a demo with this a little later on.
Okay.
I use this in the shop. This is a great way because let me tell you, if this thing is kicking 30,000 volts, that just proved my coil, my distributor cap, distributor rotor, all my primary ignition, everything is good. It's working. The only thing I don't know about is the actual spark plug because this is taking the place of that spark plug. So with one tester, I can either prove it's not an ignition problem or it is an ignition problem. So you can see if I have a car that comes in and doesn't run, this is one of the first tools I use because it tells me, am I chasing an ignition problem? If I got a good spark and the car doesn't run, it's not an ignition supply problem. It may be an ignition timing problem, but it's not a supply problem.
Okay.
That's a lot of information for a pretty quick test, isn't it? On a
Mr.
car that doesn't
Brian?
run.
Yes, it is.
Mr. Brian,
Yes.
is this tester going to tell you the, what do you call it, the voltage or something?
Well, what it is the gap is calibrated to a minimum of 30,000 volts. So in order to jump this gap, it has to make that 30,000. So if it's only making 20,000 volts, it won't go across this gap. It won't make any noise.
Mr. Brian,
Yes.
how often you change your spark plug?
We're going to get to that with spark plugs because that's a loaded question and that's not a 5-minute answer. So we're going to hold that till I get to spark plugs, but great question. And Del, did I answer your question okay?
A little bit. I thought it will be like there's a number that will tell you, okay, you have this so much volts. But
Okay, they do make an adjustable one. I don't use them. They don't hold up as well. First of all, they're not as accurate. They do make an adjustable one where you screw the thing out to increase the gap, and it has lines on the plastic of 10, 15, 20, 30, and so on. I do not like those, and I don't promote them. They don't hold up as well. They're not as accurate, and it's too easy to adjust it wrong. Or I'm like, here, this, I like this because this is simple. Either it's going to let the spark go by or it's not. If it does, it's good. If it doesn't, it's bad.
I see. So it's kind of like a test bulb that will light or not.
Yeah, exactly. Same idea, except for here, does it make noise and do I see a spark jump across it? But same idea. Either it lights or it doesn't. Either it works or it doesn't. So there is no ambiguity. There is no, well, if I turn it in one turn, it works. But if I turn it here, it doesn't. And I really don't know what that means. And I hate things that cause us to question like that. I like stuff that's concrete. If I do this test, I've got a clear direction. I'm going left or right. I don't want to have this, well, you know, it is Wednesday and it is going to rain today. And, you know, because that really clouds the diagnostic process. Yeah, that's the adjustable one. And I hate those.
I see. So, Mr. Brian, sorry, I have a not too smart question to ask because I hear this term so much. What exactly is a misfire? Does that mean that your car does not start?
No, great question. Okay, so a misfire is when I have some of the fuel in the combustion chamber not burned. And so I can have varying degrees of misfire. So severe misfire is something that you would feel as a driver where your engine's really running rough. And so a lot of times we call that, say, the engine's misfiring because it's not running on all the cylinders. But technically what a misfire is I have failed to properly burn the air fuel mixture inside the combustion chamber. So that can be because I don't have enough spark for the ignition. The spark is there at the wrong time. I have too much fuel. I have too little fuel. I have low compression. So there's a lot of things that can cause me not to correctly burn the fuel. But that's what technically a misfire is. And then to complicate things, I can have a car that runs on 3 cylinders that we would say is misfiring, but it's because there's no fuel going in the cylinder because of an injector. Technically, that's not a misfire, even though I would get a misfire code because that cylinder is not contributing. And from the driver's seat, I wouldn't feel a difference. So it's really, you know, when a cylinder is not producing the power that it should produce from burning the air fuel mixture is really what we tend to call a misfire. So it's
Mr. Brian, is no balance between the air and the gas and the fuel?
Right, well, exactly. So if I'm too rich or too lean, I can misfire. If I don't put spark in the cylinder, I'm going to misfire. If I have low compression, I'm going to misfire. If I put the spark at the wrong time, I'm going to misfire. Then there's degrees of misfiring. Could the cylinder misfire,
On the
but you don't
combustion.
feel it misfire? Hold on a second. My cat wants out. Come on. Yeah, come on. Cat must have finally woke up and decided it was breakfast time.
And the combustion, right, Mr. Brian?
Yeah, low compression causes it. So any of those things. So we use this tool just to try to eliminate spark as a possible cause. So I use this on a
Yes.
car that doesn't run, and I'll use this on a specific cylinder that sets a misfire code, because like you guys saw in the lab, what are the three things I need? I need spark, fuel, compression. And then I got to put those together at the correct time. So this, I got three legs to my stool to make the engine run, right? Spark, fuel, compression.
Yes.
And so with one tester, I can eliminate one of those legs. Either that leg is my problem or it's not my problem. And this is much quicker than testing compression. So that's why, so wait a minute, I can eliminate 33% of the possible issues with a tester that costs under 20 bucks. To me, that's a good deal.
Yes,
Mr.
correct.
Mr. Brown, we're saying here that 30,000 is the test point.
Right.
For late model cars. Is this something that changes where if a car came into your shop, you dial up all data and see what the test point is for that particular situation?
Nope. I don't care if it's a 1985 Honda. I don't care if it is a 1975 Impala. It better kick 30,000 volts. It better pop this tester. I've had Hondas that'll kick 12,000 volts, but won't kick 30,000 volts, not start. But if you add fuel, the car will start, it'll stay running and drive fine. So there's a headache for you. So you start going down, especially on a little carbureted car. I got a fuel problem. Because when I add fuel, the car starts and it runs fine. Turns out it was a weak ignition coil that couldn't make 30,000 volts. So it couldn't make enough voltage to start, but it made plenty of voltage to run and drive. By putting extra fuel in, we lowered the resistance in the combustion chamber, and a rich mixture burns easier. Therefore, that low voltage coil was able to start the engine when we added auxiliary fuel to it, and it would stay running. So we thought we had a fuel problem. Turned out it was an ignition problem. And that car, which took me 3 days to figure out back in early 90s, is what taught me a very important lesson, that if it doesn't kick this tester, you have an ignition problem. Because I was ignoring that, because I'd been told and I'd read that, oh, you could use this on GM vehicles, but imports wouldn't do the 30,000 volts and the 12,000 volts is fine. So that's why I have the 12,000 volt tester. And so it would kick 12,000, but it wouldn't kick 30. And I thought that was unusual, but the coil was expensive and back and forth. So and again, if I added fuel, the car ran. So I went down the fuel rabbit hole, thinking it was a fuel problem. And that tied up a couple of days of eliminating, proving that the carburetor wasn't the problem.
Mr. Brian?
And then I came back and second guessed my hypothesis that the spark was okay. And out of desperation, I put a coil on it. And the new coil solved the problem. And then when I tested the new coil, it kicked this tester no problem.
Mr. Brian?
That's good. That's a universal point of test. Thanks.
Exactly. Unless it's points or your lawnmower, this is it.
Mr. Brian?
Yeah.
I wasn't here when you mentioned, why did you say was the reason you don't like these testers, you said?
I don't like that tester because A, they don't seem to be as accurate or hold up as well. But the big reason why I don't like them is that it changes. You can change it. So if you don't get the spark that you want, then you might adjust it. Or what I find with mine is it moves on its own between coming off a car, back on a car, or you have it hooked up and it drops off and you pick it back up and put it back on. And the thing spun when you dropped off and you put it back on, and it's done that on me. I don't like it because it changes. We're trying to do the same thing. I just like this one, and they're about the same cost. I like this one because I think they're A, more durable, but B, it's calibrated for that exact performance. I never need to worry about it. I never need to check, did it move? Is it adjusted correctly? Any of that.
Yeah, I thought that maybe I was missing something, because I use this guy because he has the numbers, the voltage that you have that has to be done in order for the part to jump from point to point. Yeah, I go based on what the manufacturer is asking, but I mean the bigger the gap, the more voltage you're gonna need to gap.
Right.
The other thing, I mean, you know, because I mean, in my case, you know, right now I have a lap scope, but I mean, I didn't have a lap scope before. And the other thing that I was using, it was a timing light. You know, I just the timing, you know, the what's it called? The little loop, you know, on
the inductive clamp.
See which one was firing.
Right. And like I said, I like this. Like I said, the other one works. It is adjustable. I like this because it's not adjustable, because it's going to give me the same result every time. So I now, just like Rob asked me, I have a standardized test for every car that comes in, unless it's something old with points ignition. I have a standardized test that either this tells me the spark's good or bad. I don't need to worry about where the adjustment is. I don't need to look anything up. I don't need to do any of those things. And it just always works. And so that's why I like this. Because like I said, I have them both. And
it's just good to know, you know, different ways to test, you know, the car. I mean, you know,
I mean, we're testing the same thing. It's two different types of tester, do the same thing. I just explain why I like this one better. That's all.
Yeah.
And what I can tell you is, if it jumps this, it's good. If it doesn't jump this, you have an ignition problem. With the adjustable one, are you at 20? If I turn it in one screw, does it still work? Do I turn it out, a screw doesn't work? Again, now you're changing that gap. And now I'm trying to decide, is this coil okay with the gap, or should I make it closer? Now it's okay. Is it really bad? Is it really good? It's either good or bad. There is no, it's not subject to interpretation. And that's why I like the tester that I showed you.
Which one was it? I'm sorry, I wasn't here, I think, when you show it.
What's that?
What tester is the one that you're talking about?
The OTC 6589.
Oh, yeah, the one that, yeah, okay, yeah, I know. Okay, the other one. Let's see.
Mr. Brian?
Yes.
So here on your slide, it says the late model vehicles. How
Right.
late, what's the cutoff for the late model? And for the newer model, what's the minimum?
Right. That's a good question. So late model vehicle is a modern vehicle. For this slide, late model vehicles is anything with electronic ignition. So 1974 newer.
Oh, okay.
Yeah, late model is one of those things that it really changes based on what we're talking about. So if I'm talking about automated braking systems on late model vehicles, I'm talking what, 2005, 2010 and newer, right? So it really kind of varies based on the technology, how big that umbrella gets.
Oh.
So a lot of times it's kind of defined by when the technology changed.
Yeah, it is big change.
Mr. Brian?
Yes.
I'm just trying to process the whole thing. So, okay. Okay, going back to the Honda that you mentioned, right? That you said it was giving 12,000
Right.
volts, but it didn't make it to 30,000 volts. So the way how the system works, the more compression that you have in the engine, the harder for the spark to jump. You know, it needs more voltage.
Correct. There's
right?
more resistance. Correct.
So now, if we look back on the compression test that we've been doing, like on a running engine, you know, the first puff is that's what it is. You know, I mean,
Right.
it doesn't be more than that. I mean, it's not going to accumulate the pressure. So if it is 60 psi, and as you rev the engine, I'm assuming it will probably increase more than 60 because of the velocity that is going.
Right. That's why the snap acceleration, you get 3 times what you get from running.
So now, if we compare both things, the compression from a particular car and this tester, does that mean all the cars have to go up to 30,000 volts? Like, is that like a generic tester or?
Yeah. Any car with electronic ignition needs to be able to do 30,000 volts, period. And so again, you know, our compression is a different leg of that 3-legged stool, right? So all I'm trying to do is, a lot of diagnosis is figuring out where I need to spend my diagnostic time. I don't have time to test everything. I want to do some high-level testing, either tell me something's good or I have a problem here. It's not going to tell me what's wrong. It just tells me I don't have a problem or I do have a problem. And that's where that tester comes in, because if it makes spark across the tester, that means I've either got a fuel problem or a compression problem. But if it doesn't make spark across the tester, I have a spark problem. That doesn't mean I stop testing. I also still might want to check for fuel. I might even want to still check for compression if I don't think something's turning. But I will check for fuel also. And the reason why I check for spark and fuel when a car doesn't run is because it helps me exclude what could be bad. So if I have no spark and no fuel, we use like a crank sensor or cam sensor for both of those things, because that's how the computer sees the engine's turning around. So if I don't have spark or fuel, I'm thinking it's an input sensor. But if I have fuel but no spark, that means the engine knows it's turning around, means it's putting fuel in the engine. I just have no spark, so I need to look at the schematic and see where that information separates. So that helps me exclude what can't be wrong or prove what could be wrong. So if I have no spark and no fuel, and neither is getting turned on, it's time to go check, see if I have a crank or cam sensor that's not telling the engine we're going around. But if I have good fuel signal, but no spark, there's no need for me to go do that, because we're already getting that RPM signal to the computer. It knows it's going around, otherwise I wouldn't have fuel. Same the other way, if I have spark but no fuel pulse, it's not going to be a cam or crank sensor unless the manufacturer specifically says, hey, we use the crank sensor for this and the cam sensor for that. But most of them, especially newer vehicles, they overlap, and if they don't see a signal from one, they run it on the other. So that, so again, it just helps figure out, because I can't test everything on a car in an efficient manner, but boy, I can certainly ask the right questions based on a couple quick tests. So when we get into fuel, I'll show you how I quickly check for that.
Thank you, Mr. Brian.
So it's all about, I mean, I'm here to tell you one of the most overwhelming things is a car that doesn't run. I don't care if you've gone through the whole program, 900 plus hours later, I have students that are, they've been with the program a long time and they have a car that comes in and doesn't run. It is the most intimidating thing. They know how all the systems work. They know what they're supposed to do. They've studied them. But putting that knowledge into an order of diagnosis, putting that knowledge into an order that we can, hey, let's check this, let's check this, let's check this to get a direction, is not something that the CDX book covers. It talks about the how, the why, let's take it apart, let's cut it apart, let's look at all that stuff. But it really doesn't tell you, how do I figure out if it's my problem? It may talk about how to test individual things, but why would I test 50 things just guessing, right? I want to get a direction. And that's what that tester was all about. That's what this discussion was all about, was just, again, this is one of the legs on my stool. I need to figure out, is it a problem?
Yeah, no, it's good to know, different ways to, test the car.
Absolutely. So we already talked about current flows through the switch and primary windings, creating a strong magnetic field. When the current is interrupted by the switch, the magnetic field collapses. Secondary windings have more turns than primary windings, and up to 100,000 volts is induced. So here in this picture, high voltage shoots out of the high voltage terminal. So we can see here the switch is closed. Now the switch could be my breaker points. It can be an ignition control module. It's just a switch. It's controlling the current flow. So with the switch closed, we're inducing, we have current flow through the primary windings. When we open it up and collapse the field, now we induce voltage into the secondary windings and we get our output spark with a minimum of 30,000 volts. So that is what we're doing. So in order to fire that, so you can see why if I only have one coil and 8 cylinders, that coil is working a lot harder than if I have 8 coils with 8 cylinders. Right? They're not working nearly as hard because they only need to do it once for each cylinder, each cycle, compared to 8 times per cycle. What is the minimum acceptable voltage for an ignition coil output on late model vehicles?
3.
Number 3, 30,000 volts. And that, I'll tell you right now, I'll warn you, that is an important number to me because that is such a critical, it's good, it's bad. I can't tell you how many people I've seen with a screwdriver looking at a spark with a spark plug wire and looking at it jump to something going, well, we got spark. I don't know why it doesn't run. Did you check it with the tester? No, I got spark. go get a tester. Guess what? It doesn't make 30,000 volts. You spent the last 2 days on a problem you would have found in the first minute of testing.
That's everyday life.
You know, so having seen that and having seen professional technicians do it, seen a lot of students do it, that's something that when I teach, I don't want you to do it. And that's why I give you tricks so it doesn't happen to you. So we are actually at an okay stopping point. And the reason why I say is I have to go to campus today, and I want to make sure I get there because I got to meet to finally possibly get our Wi-Fi fixed. I've only been trying to do that since November, so I don't want to miss the meeting. Plus, we're going to get into types of ignition systems. And I'd like to do this in one shot tomorrow instead of breaking in the middle. So I'm really at a great stopping point. We've made good coverage on the slides. And we're going to start with the breaker point system here. And then we're going to evolve through the different systems. And you're going to see we spend a lot more time on the breaker point system than we do anything else, because that's our foundation. Kind of like when we studied electricity, we spend our time on the basic electrical, then we don't need to spend so much time on, here's how headlights work. Well, it's a series circuit. We have a load. I mean, it's like, okay, I get that. So I'm going to go through because this has in some ways the most components in it. We also control timing here. So I'm going to get into ignition timing, all those things. I will have a lab coming up on ignition timing, where you'll be going to the bar website and doing that, which I'm not going to activate till after I talk to ignition timing. So that might not even be till Monday that I activate that. So like I said, this is a big module. We're not going to finish up with ignition tomorrow. Ignition is going to go into next week. And then after ignition, we get into fuel. But this is, because there's a lot of similarities between fuel and ignition, as far as, especially on modern vehicles where we're controlling it using some of the same sensors and some of that, I cover a lot of that in more depth in ignition before we move into fuel. So that way, when I say, oh, we're using the crank sensor, we've already really looked at how we're using it in ignition or the cam sensor. So we're not plowing the same field. So that's another reason why ignition is pretty big. But on that note, we're going to get into our ignition systems tomorrow, break them down by component, show you the differences of them, look at the current flow, and solve the mystery of the primary and the secondary side of the distributor. Because even though they're not electrically connected, they're physically connected. And that always leads to a lot of confusion. So we're going to separate that out also. So on that note, I'd like everyone just to have a great rest of your day and enjoy, because especially since I went 10 minutes over yesterday, I wanted to get it back to you today.
Okay, thank you. Have a safe trip.
Make sure you use
Bye,
the
Mr.
restroom and
Yeah, make sure I go before I go, and yeah, exactly. So
safe travels out there on the road. It's supposed to be getting wet here soon.
I know. Yeah, I didn't plan the best day, but it was the only day I had. So say la vie. All righty, take care, everybody.
Thank you, sir.
Everyone,
Have a good day. Happy weekend.
Thank you.
Everyone.
Happy weekend. We got another day.
Brian.
It's a
Thank you
most
so much.
interesting subject.
We still
today.
have Thursday. It's not happy weekend yet.
Yeah.
Most interesting subject today we learned.
Good.